Hi everybody, Patrick here from EngineeringShock.com and ElectronicLessons.com. Today I'm going to show you how to build my logic conditioner circuit. Now the logic conditioner was built and designed specifically for the ES6928P voice recognition system, which I sell at EngineeringShock.com and ElectronicLessons.com. I'll also be selling these as modules, fully built and tested, but you can buy it as a kit for a few dollars less. So if you have the DIY spirit in you, you can go ahead and build it yourself. The logic conditioner board has 4 inputs and 8 outputs. There are 3 modes of operation. There's the logic double out output, which changes 4 inputs to 8 outputs. If you're more interested in seeing how it works, I have a video. My most previous video gives you a full demonstration. This is more of an assembly video. Another program within allows for you to take the 4 momentary inputs and turn them into toggling outputs. So if you get a pulse at the first input, LED 1 will turn on. It'll stay on until another pulse hits the input 1 input. And so it's a toggling feature. And the last mode of operation is a combination lock. So if a pulse hits input 1, input 2, input 3, input 4, in that order, you can make yourself a voice recognition combination lock. Or if you don't have an ES6928P voice recognition system, you can just make your own simple combination lock by putting a pulse on input 1, input 2, input 3, input 4 in that order, and LED 1 will turn high. And all of the outputs are interfaced through the side, so LED 1 corresponds with out 1, LED 2 corresponds with out 2. It's TTL logic. You can interface it with your PIC, your Arduino, your stamp, your TTL digital circuit. There's also a 5-volt pin and a ground pin, so you can easily interface a regulated 5 volts and ground to your external project. You can also use the toggling feature, so you can have a momentary output or you can have a toggling output. It's a really neat design, if I don't say so myself. And if you really want a full demonstration, check out my channel and look back at our last video. Our last video gives you a full demonstration on all the different options you have with this fun and simple little circuit. So let's see what the kit has to offer. Let's put one together. There are 8 470 ohm resistors, 7 10k ohm resistors, a single 0.1 microfarad ceramic capacitor, 2 10 microfarad electrolytic capacitors, a programmed PIC IC, an 18-pin socket, 2 header connectors, 2 3-pin headers, 8 red LEDs, 3 2-pin terminal blocks, and a 7805 5-volt regulator. So first of all, let's do the resistors. All of the resistors are labeled: R11 470 ohm, R10 470 ohm, R9 470 ohm, R12 470 ohm, R5, R6, R7, R8, 470 ohm, R1, R2, R3, R4, R13, R1, and R15 are all 10k ohms. Now they're all labeled. You shouldn't have any problem here. Just make sure that you're following the footprint. Now resistors aren't polarized, so just solder those into place, and we'll do our capacitors next. Okay, I lied. We're going to do the capacitors and the LEDs in this step. The ceramic capacitor, the 0.1 microfarad, is placed in the seat 1 slot. Right here it's labeled 0.1U, seat 1. It's not polarized. Place it in either way, it doesn't matter. But the C2 and C3 slots are labeled C3 10U, C2 10U, 10U being 10 micro. Now notice that there is a long pin and a short pin. The long pin goes in the positive slots, which are on the left. There's a little plus sign indicator on the left sides of the footprint from this perspective. So make sure that your long leads go in the left slots, the slots with the positive signs. If you turn them around, you power it on, your circuit might blow, or your capacitor might blow. And you don't want that. So again, long pins in the positive sides on the left here with a little plus sign, and short pins on the right. And that goes for both of them. Now the LEDs, there is a long pin and a short pin as well. All of the long pins go on the outside. The short pins go on the inside facing the LED and the number. The footprint has an LED number, in this case LED 8, LED 7, LED 6. The negative side goes facing the chip and the resistors, all of the long pins face the outside. So solder those into place, and then next we will do our 3-pin headers and our 7805. The 7805 goes in the 7805 slot. The back, the ground, the silver backing, faces the white background here on the footprint. The writing should face the capacitors, so just like that, except for put it flush with the board. The 3-pin headers go here. They really only fit in one way. Make sure they're flush with the board because you're going to be putting header connectors on them. So solder those into place, and then we'll do the sockets and the terminal blocks and we'll be done. When you're done the last step, make sure that you put your header connectors on so you don't lose them. They fit right on here. I'm not doing it because I'm going to test it in the default mode that requires that no connections be made. Anyway, let's get on to the socket. Socket's very easy. There's a notch on the left side of the socket. There's a notch on the left side of the chip, and there's a notch in the left side of the footprint. Match the left side of the notch up to the left side of the notch on the footprint, solder that into place, and match the notch on the left side of the PIC into the left side of the socket. Turn it around, you're going to fry your IC. Make sure you line up those notches from a bird's eye view. The terminal block's very easy. There is a terminal side, there is a plastic side. Make sure all of the terminal sides face outwards, or else you're going to have a heck of a time placing your wire connections. So wire those into place, we'll power it up and we'll test it. There is also, I forgot to mention, an LED power saver, meaning you can turn the LEDs on and off by shorting the little 2-pin header here. It's called LED space EN for LED enable. If you short those, the LEDs will turn on. If you don't have them shorted, the LEDs will not turn on. And I've done this because, again, LEDs take power, extra power. So if you know how the circuit's functioning, you can just use the outputs. Again, just so you can understand what I've got here is there's a 2-pin header called LED EN. It's labeled on the board. Then there's 5 volts, ground, out 8, out 7, out 6, out 5, out 4, out 3, out 2, out 1. And out 1 corresponds with LED 1, out 2 corresponds with LED 2, and so on. So I'm not going to give a full demonstration here. If you want to see a full demonstration of all the features, check out my previous video. I don't want this to run on too long. I've got no connections made on my headers, so I'm going to plug it in. 7 to 12 volts DC. 1, 2, 3, 4, 4, 2, 3, 1. So that is the toggling mode, because it's a moment when I've programmed my commands on the ES6928P to be 1, 2, 3, and 4. I could have it cockroach, jelly beans, and it did. But I mean, and I've got output 1 connected to in 1, out 2 connected to in 2. Out 3 connected to in 3, and so on. And on the power side of things, the upper pin is labeled V+, the bottom pin is ground. I just happen to be sharing the same 9-volt power supply to both the ES6928P and the logic conditioner. And so by default, it does the toggling mode. The output will go high for about half a second, and that triggers a toggle. So those can be used to drive relays and whatnot. Anyway, that's just to show you how to test it once you've assembled it. You don't need to use an ES6928P to drive this logic conditioner. The logic conditioner has some fun different options. So if you have any questions, please don't hesitate to ask. For full demonstration, check out my videos, and thanks for watching.